This is Mrs. Dinkelman, and I'm going to go through the notes for 5.3 with you, which is called approximating with the tangent line. Sometimes this is also called local linearization or just linearization. If you look at the picture on example 1, basically what we're saying here is we're going to use the tangent line and figure out where it crosses the x-axis potentially, use that as an approximate for where this might cross the x-axis. And certainly, the closer our tangent line we choose, the closer our approximation will be. So let's go ahead and look through this first example. 2, -2 is a point on that at the actual circle there, and we want to use the equation of the tangent line through that point, and then we'll actually figure out what's going on with 2.1. And really, traditionally, the reason we would do this is plugging a 2.1 by hand if we didn't have a calculator into this circle would be a little bit more difficult than plugging it into something that's linear, which you'll see is much easier. Okay, so we're going to have to do the derivative here implicitly because of the mixture of the x's and y's, so let's go ahead and do that first. So 2x dx plus 2y dy plus 2 dy equals 0, and I'm going to do a couple things at once here. These two things with dy's in them, I'm just going to factor the dy out of that. And then I'll move this 2x dx over to the other side. So we have dy dx equals -2x over 2y plus 2. And then they give us the point in a couple locations here that they want us to plug in. So we're going to plug in 2, -2 here. Lots of 2's. Okay, so -2 times 2 is going to be -4. And then this is going to be 2 times -2, so that's going to be -4 plus 2. So -4 over -2. So 2 is our slope. So let's go ahead and write our equation of our tangent line. So y equals slope, x minus the x-coordinate, that's an x, plus the y-coordinate, so that's -2 in this case. So that's all just normal writing the equation of a tangent line. And now what they're really wanting us to do is take that 2.1 and plug it in here for x. And so we're going to use the tangent line to approximate what's going on at 2.1. So I'm going to try to sneak it in here. So that's going to be -2 times 2.1 minus 2 plus -2. So in here, we're just going to end up with 0.1. And so -2 times 0.1, -0.2 plus -2. So we're going to approximate that it's -2.2. Okay, so again, just to recap the steps, we found the derivative so that we could find the slope of the tangent line. We wrote the equation of the tangent line, and then we just plug in that x-coordinate that they want us to. All right, let's continue on. And we're going to do when the x-coordinate is 1.9 for part B here. Now you'll notice that, at least here, Gary picked numbers that were close to 2 because that's the x that we approximated the tangent line at. So we would want to make sure that we stay really close to 2 for our approximation to be a good one. So let me scroll up just a tiny bit more, I guess. Take a peek at that tangent line we have written there. So again, I'm just going to take this tangent line that we created earlier, and now we're going to plug in 1.9. So -2 times 1.9 minus 2 plus -2. So this is going to be -2 times -0.1 plus -2. So positive 0.2 plus -2, or -1.8. And I guess what we should probably do here on both of these is say that we think that this is approximately what happens if we plug, I was going to use F notation, but that's not going to work. But our point, I guess what I should say is 1.9 comma -1.8. And really that's an approximation there. I won't use function notation since that doesn't quite work. Okay, number 2. On this one, they just give us the information to write the equation of the tangent line. Again, if you see there, it uses that phrase local linearization. That's really just them asking you to use a tangent line to approximate. So we're going to use, again, in your nightmares, hopefully you're hearing me say that you need a point and you need the slope. That's from here to write the equation of the tangent line. So y equals -2 x minus the x coordinate plus the y coordinate. And now they want us to plug in a 2.01. So -2. This is one we can use that approximate symbol on, by the way. So on this side, I'm going to put f of 2.01 is approximately. Okay, so then we have -2 times 0.01 here. And then we have -0.02 plus 3, which is 2.9